Competition, and in this lecture we will be starting with our next topic, that is NFA, or non-deterministic finite automata. Alright, so let's get started. So in order to understand NFA, let us first recall what were the properties of DFA, or deterministic finite automata, which will help us to differentiate between NFA and DFA. Okay, so here we have our deterministic finite automata, which we have already studied before and also discussed many examples of this before. So here I have taken a diagram of a DFA, which we have already discussed before, and we will be using this diagram as a reference. So deterministic finite automata, the word deterministic, it comes from the word determinism. So from the word itself, we should understand that it is already determined, or we have an assurance. And of what do we have an assurance? So in a DFA, given the current state, we know what the next state will be. Alright, so what does it mean? Suppose we have a DFA here, and suppose we are focusing on this state, that is state A, and it says that given the current state, that is the state A, we know what the next state will be. If I am in the state A, and if I get input 1, I know that I will go to state B and no other states. And if I get input 0, I know that I will go to state C and no other states. So given the current state, we are sure about what is the next state on getting particular inputs. Alright, and then it has only one unique next state. So suppose again I am seeing for state A, I'm in state A, and if I get input 1, it goes only to state B and not to any other states, right? So it has a unique next state. On getting input 1, it goes to the next state, that is B. It does not go to any other state. So on getting certain inputs, each state has a unique next state, right? So even if I take for state C, for example, if I get input 0, it goes to state A and only to state A. On getting input 0, it does not go to any other state other than state A. So it has a unique next state. And it has no choices or randomness, right? Suppose I'm in state A and I get input 1, it has no other choice than to go to state B. It does not go to any other choice other than state B. There are no other choices that it has to make. It is sure and it knows that it has to go to state B. And it is simple and easy to design. Why is it simple and easy to design? Because we know that on getting certain inputs, we know to which state we have to send it. So we just have to design it, showing the transition from one state to another on getting certain inputs. So that was about deterministic finite automata, and that explained the determinism to us. Now, what is non-deterministic finite automata? Okay, so non-deterministic finite automata, it comes from the word non-determinism. So it comes from the word non-determinism, and what does this mean? So here I have a diagram of a NFA, which is non-deterministic finite automata. So in NFA, given the current state, there could be multiple next states. We know that in DFA, given one state, there is only one unique next state. But in NFA, or deterministic finite automata, as I have shown here, given a current state, there could be multiple next states. Now look at this. We have a state A here, and A on getting input 0, let's see how it behaves. A on getting input 0, it could stay either in A itself, or it could even go to state C. It can have multiple next states. On getting input 0, it could either stay in A or go to C. And let's see on getting input 1 what happens. On getting input 1, A could either go to B or A could also go to D. So it has multiple next states. Now the question is, how do you choose to which state it goes on getting a certain input? Because it has multiple next states. So it says here that the next state may be chosen at random. We may choose the next state at random, just randomly you can choose it, or all the next states may be chosen in parallel. You can either choose the next state in random, or you can choose all the next state in parallel. That means you could simultaneously choose all the next states for a particular input. So that is about non-deterministic finite automata. And here you see something different which we have not seen in DFA, that is a edge that is labeled by epsilon. So what is this epsilon? I've already taught in the previous lectures that epsilon actually means the empty string. So this means that this state could also accept an empty string or an empty input, and on taking that empty input it can go to another state which I call state E. So this concept of epsilon, it comes only in non-deterministic finite automata. It is not there in our DFA. So if you see an epsilon, or if you see that a state is going to multiple states on getting the same input, then you should understand that it is a non-deterministic finite automata. So when we take more examples in the next lectures, it will become more clear to you. So I hope this made the concept of non-deterministic finite automata, and you could also see the difference between deterministic finite automata and non-deterministic finite automata. Thank you for watching, and see you in the next lecture, where we will be seeing more examples of non-deterministic finite automata.